The setup procedure is initiated by specifying the port flow type of simulation. Afterwards, the geometry is considered by opening the Design Modeler application. The units are set as millimeters, and the geometry file is then imported. Geometry is generated and then the input manager is considered. This is where all the parameters are set up, such as the cylinder line faces, the symmetry face, and the post-processing planes, which in this case are set at 30, 45, and 60 millimeters below the surface of the assembly. Next are the inlet and exhaust valves. The inlet valve body and inlet valve seat have been selected, as well as specify inlet valve lift at 2 millimeters from the start. The same is repeated for the exhaust valve by selecting the corresponding body and corresponding seat, while the exhaust valve lift has been left at 0 millimeters or as a deactivated port from the start. Inlet plenum face has been selected and its type is hemisphere, as well as 100 millimeters for the size. Cylinder extension length limited to 130 mm and the plenum size for the outlet plenum at 160. The model is then decomposed, and by going back to the input manager, an input parameter has been created for the valve lift. Next are the meshing settings, which from the start are retained as default. Meshing is then generated, as it takes a little while for the system to cover the full assembly with the necessary cells and nodes for simulation. Afterwards, the mesh is updated and then edited furthermore in order to increase the reference size of the cells to 3 millimeters. This reduces the overall number of the cells in order to comply with the limitations of the software. Further monitors have been created as volume type for turbulent kinetic energy, turbulent dissipation rate, and turbulent intensity, as can be seen from the 3 selected monitors. The full project is then imported by setup into Fluent as double precision 3D dimensions file. In the run calculation type, the overall number of iterations have been limited from 2000 to 1200 in order to relax computational time and effort. An output parameter for the mass flow rate has been created as a flux time type report, conveniently named mass flow rate, at the IC outlet. This is then created as an output parameter which can be viewed with the closed loop. 2 further design points for the inlet valve lift have been created, so in total 2, 6 and 10 mm valve lift for the inlet valve are created, after which the simulation is initiated, the process of which can be viewed from the bar below. After a successful completion of a simulation, an HTML report is produced, which displays various information for the setup, parameters, as well as the results. In this case, various information such as the number of nodes and elements for the model, the input parameters, and the vector results on the 3 post-processing planes as well as the cut plane are displayed. Further analysis of the results are completed in Fluent itself by creating vectors. In this case, a specified vector analysis for velocity magnitude with altered scale is being produced on the cut plane. This displays the infamous tumble motion as the circular motions within the cylinder. In addition to this, altered analysis has been produced for the horizontal post-processing planes, displaying velocity magnitude and the significant swirl motions on the post-processing horizontal planes. Further analysis have been completed for turbulence. In this case, displayed is the turbulent intensity on the cut plane. It is important to stress that the size of the arrows are for velocity magnitude, but the spectrum depends on turbulent data.